Before we even reach the middle of August, parts of Central and Eastern Europe are on course to record temperatures sitting 10, 11, and possibly 12 degrees Celsius above normal for this time of year. Multiple long-range forecast systems show a sustained, wide-ranging heat event that is expected to persist for weeks, driven by a powerful atmospheric setup that has been locking in all summer. As this atmospheric system shifts across the continent, the data is updating rapidly. Hit the subscribe button right now to follow along as we track this event in real time. The severity of this forecast stems from the timing. This extreme thermal energy is hitting a landscape already depleted by a pre-existing environmental crisis, stripping the land of its ability to absorb additional heat stress. Europe entered this summer with a deep accumulated moisture deficit. Across France, Eastern Europe, the Baltic region, and Scandinavia, soil moisture is already severely depleted. This diagram shows how parched soil actively amplifies ambient temperatures. Normal dirt uses evaporating moisture to cool the surface, but when the ground is dry, that buffer is gone. The land simply absorbs and radiates extreme heat directly back into the air. You can see this visible strain on major infrastructure right now. Critical river systems, including the Rhine, the vast Danube River, and tributaries of the Po, have heavily receded, exposing vast stretches of sandbars and shallow beds. This landscape stress is actively fueling intense, widespread fires across France and southern Europe. The vegetation is parched and sitting at critical fire weather thresholds. Because the land itself has absolutely no buffer left to absorb additional thermal stress, a heat wave arriving today is significantly more lethal and much harder to recover from. This 3D meteorological map illustrates the specific atmospheric engine driving this crisis, a high-pressure setup known as an omega block. A massive high-pressure dome sits anchored over the core of Europe, flanked by deep low-pressure systems to the west and east. When this pattern locks in, the central high acts like a physical shield. Any rain-bearing weather fronts attempting to cross from the North Atlantic are immediately deflected up and around the edges. While it blocks the rain, it actively pulls in extreme heat. A Saharan air mass is being pumped directly northward, funneling straight into the continental interior. Omega blocks are notorious for their persistence. They trap the continent beneath a stationary heat engine that will continuously bake the surface until the atmospheric weather pattern finally breaks. This projected thermal map identifies the exact epicenter for the first half of August. The most extreme deep magenta anomalies are heavily concentrated over a core zone running through Slovakia, the Czech Republic, Austria, Hungary, Serbia, and Romania. Forecast models place this pocket at 10 to 12 degrees above the seasonal average. Daytime highs will push deep into the 40 Celsius, bringing the distinct, terrifying potential to completely shatter national temperature records. Secondary risk zones are facing severe conditions of their own. Northern Portugal, central Spain, and France will run 6 to 7 degrees above average, heavily compounding their already serious fire risks. Northern Italy faces compounded infrastructure threats, where the heat will simultaneously strain power grids, public health systems, and heavily depleted water supplies. There are a few geographic exceptions. Thanks to the jet stream, countries like Norway, Sweden, Finland, and Scotland will largely experience normal or even below average temperatures. But across the rest of the map, the sheer geographic footprint of this heat dome makes it a sweeping, continent-wide test of our infrastructure resilience. This chart tracks the frequency of these high-pressure blocking patterns over time. According to a 2025 study, these configurations have nearly tripled in frequency since the 1950s, driven by shifts in the jet stream. Right now, a rapidly strengthening El Niño is acting as a short-term amplifier on top of that structural trend. Meteorologists place the probability of this warm, dry pattern extending well into the autumn at over 95%. This creates a severe secondary danger for September. When Atlantic rain finally breaks through, this hardened earth will have lost its capacity to quickly absorb water. A severe drought does not safely end with heavy rain. It transitions directly into a flash flooding hazard. If you are in the central and southeastern core, you need to take practical preparation steps now before the heat peaks. Identify local cooling centers and check on elderly neighbors. Be highly cautious of dangerous nighttime temperatures in urban areas, which prevent the human body from safely recovering between daytime heat exposures. Those in agriculture, construction, or logistics face severe heat stress risks during afternoon shifts. You must also monitor air quality, as these conditions favor dangerous levels of ground-level ozone. Keep checking updates from your national meteorological services. The exact peak days for specific cities will become clearer as the month progresses. With a strengthening El Niño reinforcing long-term structural climate shifts, the patterns of heat and drought established this spring are not breaking. They are evolving and intensifying as we move toward the autumn months.